Hello and welcome everyone. I'm Nicholas Bosk. I work in the SureChEMBL team as a patent data scientist and informatic expert. And I'm joined today by my colleague Cote Falaguera, who is a postdoc in our group. We are going to talk about navigating patent data with SureChEMBL. During this webinar, I will introduce SureChEMBL for those of you who do not really know what is this self-service hosted at the EBI. Then I will present the user interface. I will talk about the different ways of downloading the data, and then we will have 10 minutes for the Q&A. So SureChEMBL is a database of annotated patents, and by annotations, I mean chemical annotations and biomedical annotations. It was first named SureChem. It was developed by Digital Science, a company from the Macmillan Group. And it was rebranded SureChEMBL in 2013 when EMBL-EBI acquired SureChem. And since that, it was maintained and kept as it is. It's only last year that we introduced a new version of SureChEMBL that rely on a new system and a new user interface. At the moment, SureChEMBL gives access to 167 million patents. From that, about 20 million are chemically annotated, and that represents 20.5 million compound structures, unique compound structures. We also we have introduced recently the biomedical annotations that are still only generated on the fly, which means that you cannot download them, and also we don't enumerate them. Why is SureChEMBL important? And the underlying question is, why is searching chemical patents useful? It is important for companies and organizations who are interested in knowing if they can operate in a certain area, especially in drug design. You want to know if the compound that you are developing, if it's already protected by a patent or not. So it's important to search as soon as possible during the project if you have the freedom to operate. It's also a question of competitive intelligence. You want to know what your competitors are doing, then SureChEMBL is the place where you can find this information. But from a scientific perspective, it's also a way of accessing the state of the art in terms of chemistry, to know the evolution of compound reactions, for instance, or what are the new compound structures that are generated every year. This information can be used for citations and also references. So I would suggest that not to restrict to scientific publications when you are writing your articles. Patents also contain a lot of science, and it's usually very well described because the ultimate goal is to protect an invention. So this is also a source of citation. But also, most of the knowledge in chemical patents will never appear anywhere else. And in our field, that means compounds, scaffold, reactions, but also biological target disease indication relationships. And studies has shown that it takes usually, on average, 3 years for this knowledge to be transferred from patent to journals. Of course, it can be less, but it can also be much longer or never. In terms of patent data coverage, on this table, I show you that we have access to data from the EPO, the JPO, USPTO, and the WIPO. So that's respectively for European, Japan, US, and the worldwide offices. And for the different authorities, we get access to patents from different starting line. And we also get access to different sections and metadata attachment of the patents. But for the majority of the patent that we have in SureChEMBL, we have access to the full text. That means the title, abstract, claims, and descriptions. We usually get access to the patent documents between 24 and a week, and it takes us between 48 hours and a week to annotate the patents and to make them available with the annotations. So I would say that it should take maximum 2 weeks between the publication of a patent by the relevant authority and the access of the annotated patents in SureChEMBL. So historically, SureChEMBL is a database of chemically annotated patents. So let's talk about chemical compound identifications. This is a summary of the pipeline. It's a fully automated pipeline. We get access to the patent documents through our service provider, iFileClaims, and we get access to different files. So from the text that has been extracted through OCR, we do text to structure using different methods where the compound names are converted into structures. From the images, we do our own OCR, and the structure represented in the image is extracted. In the easiest case, we also have access to the MOL files. That's only for the US patents, and then it's straightforward to register this information into our database. Ultimately, we get access to the structures of the compounds in these 3 different ways, and they are all registered in the same way in our database. In terms of evolution of the data quantity in SureChEMBL, when I was preparing this slide, I had a look at how much data we had in 2015, the year before the SureChEMBL paper was published, and we had at that time annotated almost 15 million patents and extracted 17 million compounds. The projection at that time was that if we keep extracted 80,000 new compounds per month from 50,000 annotated patents in 2024, so this year we should have extracted compounds from almost 20 million patents for a total or just over 25 million patents. But in reality, this is where we are at the moment. We have annotated much more patents than we expected 10 years ago, 28 millions, and with also more unique compound extracted from this patents. So it shows that more patents were submitted and approved by the patent authority in this for the US, Europe, Japan, and worldwide. And obviously, we annotated all of them, and it resulted in slightly more compound structure than we expected. But now, if we compare the SureChEMBL chemical space with other chemical space, it's quite interesting to see that the overlap is relatively small. For this exercise, I used UniChem, which is a compound cross-referencing service, also hosted by the EBI. And I excluded PubChem for this analysis because PubChem historically is tracked SureChEMBL compound, so the overlap is very high, but obviously it's easy when you share the same compound collection. So it's quite interesting to see here that for the two other databases that offer compound information, and in particular bioactivity data, ChEMBL and BindingDB, the overlap is very small, with just around 500,000 compounds that are present in SureChEMBL and in these two other data sources. So it means that for the vast majority of the compounds in SureChEMBL, we don't have access to the bioactivity data. It doesn't mean that there is no bioactivity data. It is likely to be mentioned in the patents, but SureChEMBL does not extract the bioactivity data at the moment. I know that BindingDB is doing this work for a small number of patents, so it's an improvement, but we are not yet there in terms of knowledge for the patent compound. Now let me guide you through the user interface of SureChEMBL. This is the landing page of SureChEMBL. It's minimalist, a single page that gives you access to all the functionalities. You can you can search for patents and compounds through the unique search field, the structure search, and also the query assistant, which three of them, I will describe that a bit later. You can also download the data through our API, the data client, and our different download terms. Let's now focus on the text search. We offer full text searching capabilities for the whole patent document, and for the metadata and bibliographic, we have a system using keyword-based searching. This metadata gives you access to different entities that I'm not going to enumerate here. You have the list on this slide, and for a detailed list of all these fields, I refer you to our SureChEMBL wiki, which is quite exhaustive. The text search is powered by Solar Index backend, and we update it every night. So every time we get new patents, the next day they are available to the users. It supports Boolean operators for combining conditions. You can use parentheses for nesting conditions. Support wildcards, exact, proximity, fuzzy searches. And below this field, square field, we also offer pre-configured filters to select easily which authority you want to search in which authority you want to search. a filter that will only return patents that are likely to contain small molecules, and also a filter to select a given date or a time period. The SureChEMBL patent number, or SCPN, is a bit different from the patent number from the authorities, in the sense that it combine the country code, the patent number, and the kind code. So you have example here. Obviously, for us, it's important because we combine patents from different authorities. So this way, it's very easy to identify where they come from. Also, and it's a recent improvement of our interface. It's now possible to search by patent number without having to use any field name. So the patent number can be just entered in that way, and you can even search for multiple patent number at the same time, and it will return you only the corresponding documents. The query assistant is also a relatively new addition to our user interface. Basically, it gives users with no knowledge of our solar index and who are not particularly keen in learning how it works, which I might understand, a way of directly selecting the field of interest, and you can enter a value that will be searched. You can, this is a condition. You can add multiple conditions to create your query. So in this example, I'm interested in finding every patent that contains the word kinase in the title and the word cancer in the abstract. The user can also expand this query manually directly in the search field. And lastly, we also have an option to create a group condition that allows to create a condition where several values are entered for a given field name. So in this example, we are interested in finding all the patents where the inventor is one of these pharma companies. No matter how you query the system, either entering yourself your own query or using the query assistant, you will get the result will be a list of patents that match the query. You have the number of hits and a pagination that allows you to navigate through the results. You can download the list of patents, and then you can click on a patent of interest. Here you have the patent view, which in a single page gives you access to all the information that we have collected for the patent. So in the main page, you have the text with the attachment present, and this text is annotated. It is annotated for chemical entities, but also for biomedical entities, meaning disease, target, and mode of action of the compound. So that's going to be a term like inhibitor, activator. In the second tab of this view, you have a summary of all these annotations. In the third tab, you have the bibliographic metadata. And in the fourth tab, you can download the original PDF that was published by the authority. If you use the navigation panel on the left-hand side, you get a way of navigating through the different patent sections, but you also have a button. If you click it, you can download all the chemical annotations for the patent. The biomedical annotations are not yet accessible for download. It's a work in progress. It will be available soon. If you click on chemical annotation on the patent, you get access to further information for this compound. It gives you the structure and also the structure in different formats, SMILES and INCHI. If you click on details, you get access to the patent in which this compound is described. And also you have another field that gives you the UniChem cross references. I will come back to that in a minute. That was for the text search. You can also use SureChEMBL to search for compound structures directly. We offer 4 methods: substructure, similarity, identical, and connectivity. In substructure, you are interested in finding all the structures that contain your query structure. In similarity, you want to find all the structures that look alike your query. Identical, you are looking for this exact structure. And connectivity is similar to the identical structure, except that we ignore the stereo isomery of the molecule. No matter which type of search you are using, if a system finds matching molecules, it returns you the list of structures with, again, a pagination that allows you to browse through these different structures, and you can download them. If you are interested in a compound in particular, you can access the details of this compound, and again, it shows you the patent list, the patents where this compound is mentioned. So when you look at a compound in particular, noting that you can access a compound by its SureChEMBL ID directly through the URL, where you just have to type the SureChEMBL ID after the classic URL. You can find, using UniChem, in which other data sources this compound is available. And just to mention here that UniChem, our cross-referencing system, contain at the moment almost 190 million compounds from 41 data sources. And it's very easy to find, if you are, for instance, interested in knowing where to buy these compounds, you can check if it is in the library of a molecule provider such as eMolecule. If you're interested in knowing if there are bioactivity data available for this compound, you can check in ChEMBL or in Drug Bank. You can check if this compound is present in these data sources. So this is very easy to access information. We have documentation available for SureChEMBL. You have the link on this slide. There are a lot of aspects that I don't have time to mention in this webinar. So I encourage you to have a look if there is something that you are looking for. There is potentially the answer and the wiki. Otherwise, do not hesitate, and you can contact us. Again, you have the link on the wiki. Now I'm going to guide you through the different ways of downloading the SureChEMBL data. Again, it's described in our wiki, but to summarize here, we have a compound data dump, we have the map files, and we have the data client. The compound data dump and the map files are accessible directly through the landing page, clicking on the download links, and it opens the FTP page where you can download the different data. The compound data dumps are generated quarterly with new incremental updates, and it gives you either in text format or in SDF format the different compound structures with their SureChEMBL ID. It's similar if you download the SDF file. For the map file, we provide a bit more information. The aim of the map file is to provide an easy way of mapping the patents with the compounds that we found in the patent. So it gives a spreadsheet with the patent number and the corresponding compounds, but I will describe that a bit better on the next slide. To mention here that we filter which association patent compounds we provide in this map file. The compounds must not be a radical, must have fewer than 4 components and not and more than 6 carbons, must be organic, and its molecular weight must be between 100 and 6,000. Also, for the patents, we filter which patents we keep using this codes, using at the same time the IPC, ECLA, IPCR, and CPC classification systems. As I said, in the map file, you retrieve association information for the patent and the compound that are found in the patents. For that, we give you the SureChEMBL ID, the corresponding SMILES and INCHI key that refer to the structure of the compound. Also, the field name corpus frequency, that is the number of time a compound is found across all the sections of all the patents in SureChEMBL. For the patents, we offer the patent ID with the publication date and the field, which is the section or the part of the patent where the compound was found. So it can be the title, the abstract, the claims, the description, but it can also be found in the images of the patent or directly in the MOL file if it's a US patent. And here you have an example of how the map file look like with the first the information on the compound, the compound ID, the SMILES, INCHI key, and then the information related to the patent with the patent number and frequency and the location of the compound in the patent. Excuse me. We also generate these files, the map files, quarterly. They contain roughly 50,000 patents, except for the first dump that was generated in at the beginning of 2015, and that covers everything before 2015. So it's much larger. Finally, if the compound dumps and the map files are not enough, you can also use the SureChEMBL data client it's a way of setting up a light version of SureChEMBL that can receive daily updates of the SureChEMBL data. The instructions are described on the related GitHub page. And if you have any question, feel free to contact us. Anyway, if you want to use it, you need to access a secure FTP. And for that, well, you need to ask us the permission, and we will give you the identification login. Right. We are reaching the end of this webinar. To conclude, during this webinar, I hope I explained you why we are delivering SureChEMBL. I talk about our patent coverage, but also the pipeline that we use to identify the compounds. I've showed you the latest version of our user interface, and I mentioned the different ways of downloading the data. Something that I didn't talk about, it's the API. But there is a lot of documentation on the API in the wiki. Again, I give you directly the link here. And we also give you access to a Google Colab notebook that show you directly how to use the API with examples. So if you're interested, it's something to look at. Regarding perspectives for SureChEMBL, we are working on different new features. SureChEMBL is a project that is that keeps evolving, and we are constantly trying to improve it, improving the data quality, but also offering new functionalities for the users. So without any particular order, I can tell you that we are working on a new image to structure protocol to improve the quality of the images extracted from the images. We are on we started annotated Chinese patents. It's not yet available, but we are processing them at the moment. We want to make available the biomedical annotation through the downloads, so the users can do their own analysis. We want to show to the patents containing chemical structures, the core chemical structure directly, which is basically, and if you have a question after that, feel free to ask. It's a way of identifying the substructure of that is the most represented in the patent, and that is likely to be the one of interest for in the patent. We're also working on offering a new way of offering the data for download, and we are improving our API constantly. Obviously, we cannot do everything at the same time. We need to compromise between resources, time, and costs, but we are confident that we can offer at least most of these new functionalities next year. With that, I would like to thank our service providers, both for the annotation, but also for the provision of the data. Our funders, without them, it would be impossible to maintain and to offer SureChEMBL. I'd like to ask everyone in the SureChEMBL team, past and current, and also everyone in the chemical biology group at EBI. And thank you for your attention. If you have any questions, you can type them in the Q&A if it's not already done, and we will start answering them. Also, give you here the email address if you want to contact us directly, and also the URL of the Campbell blog post, which is also where we post updates about SureChEMBL. Campbell is our sister resource, as you can imagine. So we are using the same blog. Thank you.
Wonderful. Thank you, Nicholas. So we do have a couple of questions, but if you're able to just skip on to the next slide, we can give people a few more moments to type in their question into the Q&A box. Just to mention that we do have a couple more webinars before we stop for our winter break. You can find those on the website, training/webinars. And if you're interested to find out what we have coming up, we really recommend following EBI training on LinkedIn to see what we have in the future. I did mention as well at the start that all our webinars are recorded. This is the case for this one too, and we'll send out that recording tomorrow for you in case you want to go back through any of the sections to try yourself as you look through SureChEMBL. Okay, so I think at this point we can have a look at the questions in the Q&A box. Feel free to add more to there if you would like to do so. So, Koto, you've flagged a question to ask around downloading data. So the question was around exporting data in a CSV file. So the molecules relating to a patent. So not the full data dump, but and without the mapping, to rather a simpler file.
Yes.
If I understand correctly, the person would like to download only the compounds
Associated patent, I think.
Excuse me, can you repeat this?
So this is a question that happened early in your presentation. So I think they are referring to the moment where you search for a given patent. Is there any way to download like a CSV file containing compounds that are in that specific patent, if I got that correctly?
Yeah, I hope that it was clear that indeed when you look at a patent, it's possible to download all the compounds that were annotated, and you can download the compound in XML or CSV format.
Great, thank you. And there's also a question, well, more of a request than a question, asking if in the future it's possible to do a live demonstration of the API with some examples, and perhaps this is a potential future webinar that we could look at doing.
Yes, indeed, we could do that. I'm going to take a risk, and I'm going to move to, because I think we have a bit of time. So is it going to work?
So you will just need to reshare your screen. Yeah.
So I'm on the SureChEMBL wiki, and we have a section for the API. We have the list of endpoints here, but what we want to look at here is the examples, and this is the Google Colab notebook that I mentioned. And obviously, I don't have the extensions to. Okay, let me swap to a different web browser. That's ah. So now I'm sharing SureChEMBL here. We are back on the wiki. We have this link, and we can open it. With Google Collaboratory. And this is why you should never do a live demo when this was the plan. This is supposed to open a Google Notebook, and I don't know if because I'm sharing my screen, but this is not working. Sorry, so you would have to trust me and test yourself, but it gives you examples of how to use the API.
Great, thank you. And are there some examples within the documentation on the website?
Yes.
Wonderful. Great. Yes, there was one in the chat.
There is a question by Praveen. They say chemical identification done based on Tanimoto, which I guess is Tanimoto similarity.
For the similarity, yes, we use the Tanimoto coefficient to calculate the similarity.
Okay. Okay, so I think that was most of the questions. Was there another one? No.
There's one, just last question from Sankar. They say, from a published patent, I got a substructure. How do I take a lead from here to the possible future API, which the company is eyeing?
That is a good question. If you have a substructure, well, the first thing to do, I would say, is to search in which patent you can find this substructure. If you cannot find it in SureChEMBL, I mean it's a good sign. It means that it has not been annotated. Obviously, it doesn't mean that it's 100% sure. I would still use. I would also compare with other data sources to be sure that this is the case. If you get matches with this substructure, it doesn't mean that it is necessarily protected by a patent. You must look at if the patents are still valid, and from there you can assess if yes or not it's a good idea to work with this substructure.
For individual patents, is it possible to download all the structures mentioned in individual patents as a CSV file? What about older patents?
What about all the patents?
Older
patents?
Yes.
Well, by older, I'm not exact. I mean, okay. Well, it does not matter if the patent is new, if it's old, if it is in SureChEMBL, and that we were able to annotate the test patents, the chemical annotations will be available for download.